shoot. And
I think
the verdict is
we may actually be recording. Stand by. All
I
right,
told you to reboot your router.
So actually, I just want to let everybody know that this is the security table, and we just rebooted the internet. So you may have noticed an outage for a short little period of time, but we are back now and ready to discuss many things, even though I feel like we've already discussed many things as we were trying to figure out how to get this thing to record. Okay. The first item on the agenda / docket is an article that is entitled, "What is the Shared Fate Model?"
And so, Matt, you sent this article, Matt Coles is our turn dash and Christopher Mayo.
Oh, thank you for.
Oh, everybody knows us by now. Come on.
Yeah, we're huge in Australia too, by the way. No. Matt, this was I think you found this article here. Why don't you set it up for us? I mean, shared fate. What are we even talking about here?
It's a good question. What are we really talking about here? So, as everyone knows, there's a shared responsibility model supposedly for cloud, right? Cloud services. You're borrowing somebody else's computer and using it for your stuff. And apparently, people who post those sort of things don't want to do everything themselves, so they implemented a shared responsibility model. You have a responsibility when using cloud services to do certain things because they can't control everything. And that makes sense. You don't want them to control everything. If they did, you never have access to encryption keys, and never have the ability to, take your data away. Who knows what else? But I think that there's an understanding now that the cloud is hard and expensive, and I think maybe there's some ice in there. I don't know. Maybe there's a lot of hail. And so it isn't just responsibility anymore, but now you also share the same fate as a cloud service provider. So if, for instance, if you're relying on the cloud to manage file streaming or video or audio streaming or something like that to remote participants, if the cloud goes down, so do you. And so you're in the same. You have the same fate as the cloud provider. You can't escape it. You're relying on their services.
Okay.
How's that different from an ISP?
Good question.
I'm always dependent on whatever is beyond my router, right? My modem. I don't know what's called this week.
I miss ISPs.
Right? They were cool.
Remember, ISP used to be such a big part of our lives.
We all have ISPs here, right?
But you don't have any relationship with them anymore. Like
exactly. Today you don't know their names.
In the 90s, we used to have one in my hometown that the building is still there where they were set up. The name is slipping me at the moment, but it was a dial-up provider, and they literally had a tech support in a building, so you could actually drive to their building or stop by or whatever to see what was going on. Hey, what's happening with the internet today? It was just a kinder, gentler world.
We had Earthlink, and they provided all basic services and everything like that. I mean, so it was a lot like Google in that regard, except for they also provided internet access, dial up and then DSL, and finally.
Oh man, DSL.
I still have all those little phone adapters that you're supposed to get for DSL lines.
Okay, so so everybody here started with dial up, right?
Yeah.
What was your first modem? What speed was your first modem?
1200.
300.
300, Matt, old school.
Well, so my first computer was not mine. It was my dad's. He used to work at Digital Equipment Corporation, and he had a VT.
Okay.
So he had a
dial-up
modem. Did it?
So okay. We're not even going to go there with what you were connecting to and what computer you were actually using.
Yeah, okay, we're terminal services, right? So
300 baud, I think.
You can walk to the data center faster than connecting with 300 baud.
And it was a green screen terminal, with the clicky keyboard. Yeah, it's awesome.
But at one point, I upgraded to a VT220, which was already orange.
Ooh, fancy!
You can get simulators now, so you can reproduce that behavior in your.
You never seen my terminal, right?
All right. So dial up. All right. Did either of you have ISDN?
No.
I was trying to
you did.
remember the 4 letters. I did.
At school, yes, but never.
Do you
at home.
remember ISDN? You could have, it was basically 2 phone lines. And so you
Mhm.
could literally
could
pick up
combo.
the phone and talk to somebody, and your connection would drop down to, I don't remember what the speed was at this point. Was it
Well,
even
remember that
100
time people would get 2 phone lines in their house so that one person could be on the computer.
Oh, I
They
had
actually.
I had 2 phone lines. I ran a BBS in my youth.
Oh,
So
I
you
did
go-
not
You have
have
a
2
bank of them.
lines.
No, I
I
only
did
had
not
one
have 2
line.
lines. I had a very pissed off girlfriend.
She couldn't get in touch with you. But look what it did for your career.
True.
See, if you hadn't been a nerd that was playing on the computer, dialed into things all the time, you wouldn't be.
Fitting.
Product placement is we're big on product placement here on the security table. Okay,
But nothing
All
on the
right.
t-shirt.
okay. So, and then from so 2 of us had ISDN, and then DSL was next
Yep.
before cable. I think I had
Yeah,
DSL before
DSL and
cable
cable. Yeah,
because cable wasn't a thing yet when DSL first came out, at least in the Northern Virginia area.
never got cable. Had fiber optic.
So you went right
After
from
that.
DSL to fiber. Nice. Wow. Fancy. Okay. So we're
Wow,
all
yeah.
so that's the history of our ISP
Went
and
from-
internet
went from-
access.
Went from 56K to 10 meg.
10 meg. And I mean,
Yep,
remember
that was a jump.
T1s? 1.5
Mhm.
megabits per second. Like we all wanted it. I remember we got a T1 at the college I worked at back in 92, I think is when we went live with it. And it was like, imagining, oh, what if I could have this at home? Imagine the bandwidth, but it's like $25,000 a month in 1992 dollars for 1.5 megabit per second.
So
Yeah.
I was in college. We had obviously a T1, to the college. Must have been more than a T1 because I'm sure they were like a hub, one of those research centers. And but in the dorms, we would get fractional T1 speeds. I remember playing a text-based MUD. With like 1,000 other people around the world, and you'd still get lag. You type to the keyboard, and you'd be like, hey, shit. Wait. Of course, if everyone has ever played a text-based MUD, especially one that is more of like, you go into a room and there's a fight, it's like a little dungeon kind of thing. You're fighting a monster and the screen stops scrolling and you don't know if your character is still alive or dead.
So I had the T1 on my first startup, and I wanted a piece of that, especially in the evenings. And because there was the phone was behind the central, I couldn't like put a modem and call the phone and use it. So I actually had the modem programmed to call my home at a certain time. So I had to run home to pick up the phone to connect back with it.
To make the connection for the night.
make the
I love
connection.
it.
Wait, that's the first callback? Is that the first callback system?
That's basically, yeah.
I love it.
And I won't even tell you what I had to do to be able to watch the games in the 1998 World Cup. I actually had to get a graphics card that could get the signal from the cable company in my house. And then I would call back, connect to the computer there, sit in the office, open a window in my Linux box that had the graphics card and watch the game there play.
Oh, that's right. Graphics cards at that TV interfaces. They
Yep.
had coax cable interfaces, or
It was a Voodoo 2, if I remember correctly.
Oh, I remember those.
Did you JCC? You could get 2 cards in the same system with the Voodoo, I think.
You could
wow.
band them together. Yeah.
This is the Wayback Machine. It's making
Yeah.
me
So
remember.
that's a shared fate.
Okay, here's a quote. Here's a quote from the Shared Fate article that I wanted to kind of tee up here. The Shared Fate model is centered on the customer's needs, where the cloud service provider leverages its expertise to play an active role in the customer security. This model provides enhanced support for organizations in 3 key ways: enhanced collaboration, actionable steps and guidance, and robust defaults for cloud services. So is this really different?
I don't think so. More to the point, shared fate to me sounds like commiseration time. Let's just sit all around the modem and say how bad things are and how worse they're going to get.
Yeah,
Well,
like we're all screwed. We're all
So
screwed
I
together.
wonder, actually, as you just reread that, and as I cut the article again, I wonder if the shared fate is not from the perspective of the consumer, but of the cloud service provider. In other words, they want a more active role because in the shared responsibility model, they provide the service and you do everything else, right? You're responsible for making sure that your account is secure. You're responsible for making sure the services you use are stitched together correctly and that you're configured them properly, right? They're just providing you the infrastructure, shared responsibility model. But in the shared fate model, their security depends on you. And in the shared fate model, if they take on more of that partnership, they can steer you in the right direction or give you better full. One might argue they should have maybe done that to start with.
But
Right.
here comes the question. When you say their security depends on you, which company in the right frame of mind or in the same frame of mind would ever do that? I mean, it's not like everybody knows how to do security. I don't want my security depending on somebody else that the only relationship that I have is that they pay me.
If you're a small business and you just want to get a site up and running to do ordering and things, and you don't want to actually own infrastructure, you want a service provider that provides a lot more stuff than just simply a hosting location, right?
Yeah. But then what's
So-
my relationship with their security? You just gave me a good reason to put all the security stuff on them.
Which is the shared responsibility model.
Yeah,
Ultimately is what, even though it's
Good point.
called shared responsibility, it's really,
for a reason.
I rely upon the cloud provider to solve my problems.
But if you think about it, at the different levels of service, you can get like hardware, you can get an OS, you can get an application, you can get a serverless Lambda, whatever. Different levels of interaction with the CSP and different levels of expectation in terms of the security that you were responsible for. That to me is the shared responsibility model. But the
Right,
shared fate thing,
so the shared fate thing seems like it's coming from the perspective that that's not already happening, meaning that the cloud provider is just providing a hosting solution and you're basically implementing your own security on top of it.
Which is
the
what
shared-
that's what's happening today, at least in my experience. But I'm on this third bullet point, robust defaults for cloud services. And that one's, I'm starting to see the light a little bit on this, at least on the cloud service providers taking a different approach or strategy. Like imagine a world where a cloud service provider forced you to use Secrets Manager and you couldn't generate or release a service that didn't use Secrets Manager to manage its credentials.
there's nothing stopping me from doing my own solution and using it and just like connecting to the provider's solution to, just check a box or pass their audit or whatever. So
Yeah, but
if
you
they
wouldn't.
the TSP can't enforce that.
Well, they can lock down the APIs that you use.
Oh.
Because they own them. They own the gateway. Why? How could they not? I mean,
I create my own encryption API. How do they know that?
well, certainly, if you encrypt the data that before it makes it to the cloud, that's one thing. But
No,
within the
or
cloud,
even my own authentication. So what? What do they know? Now they're looking at my traffic. Now, even worse, now they are understanding my traffic. If they do understand my APIs, that's a great service. Let me know how the shit works because I don't know. But beyond that, how can I enforce them?
Well, that brings a good question. Can cloud providers see everything?
why would you suggest they couldn't? It's
Yeah, I
their
don't think
computers.
that's what I was
That's-
landing on that. I think they can see everything.
Wait. There's a difference between seeing and actually understanding and then being able to read or being able to interpret or whatever. They can see everything because it's their pipes. The thing is going through. Oh, look, another packet. Oh, another packet. But apart from that,
But if you do
What's
all
the-
your certificate generation inside of their certificate authority, then technically they even have the ability to see.
unless
all
it's
of the
hardware
traffic.
backed. Unless
Why
it's
would
hardware
I?
backed. Well,
Why
that's the
would I?
thing.
Why would you
You,
use their certificate authority?
if you're a small business and you don't have your own infrastructure, of course you would.
I mean, what else are you going to use?
The,
VeriSign or
the guy that
those?
wrote the application for me, he should be the one saying, no, let's not use the PSPs. Because as
How
a
many
small
developers
business,
have you? How many small business developers have you met? Because I'm pretty sure that they just want stuff to work. I mean,
they
this
know,
is why
but
this is why Squarespace exists, right? This is why GoDaddy has website building services.
yeah, but
They-
at the other side, okay, so take Squarespace, for example. Great company, worked for it for 2 years, loved it every second. And yeah, you're right. People can go into GoDaddy and Squarespace, not to make it so one company thing, and just buy a service, build their site, and so on and so forth. But even given that, what I saw personally, and this is not backed by any kind of data, people will go in, buy the basic package, get their nephew-based website up, and very quick they would need some other functionality, and very quick they would find somebody to provide that functionality, and very quick they would understand that they need a certain amount of other stuff and start putting that stuff up. So even a small business, I think that they feed the even smaller businesses of building those commerce sites for them. If you want to be actually successful in that thing, you have to invest something into it. So the point is that somebody building something like that, let's use the CSP Deeple's framework or whatever, because it's easy. But
I think
if you want to do it right, then you may want to go somewhere else.
I think we went on a tangent that the article didn't
For sure.
actually say here. So the shared fate model suggests the cloud service provider focus on delivering robust defaults for cloud services. This requires cloud providers to build products that are secure by design and by default, helping customers with the toil of securing their environment, not adding to it. So secure by default, cloud service provider providing great secure defaults results in, like, I can still change it to an insecure approach if I want to. But the beauty that I've seen in secure by default is it's usually harder for me to have to go reverse engineer, just take away the security control they've applied to put some insecure option in. People are generally lazy. And so if the default is secure, they're not going to go spend and invest the time and money to say, how can I turn this thing back? How can I go from using HTTPS to HTTP? I just want plain HTTP. Nobody's going to do that.
But help me here. The way that I see what you just said is that I'm a small business thing or whatever, and I just want my stuff to work. So I go and I put HTTP here. So now I'm relying that the CSP at the load balancer thing will say, no HTTP here, only HTTPS. And they'll deal with the whole certificate thing. And
So basically, if you add an application load balancer to a cloud instance, all this is saying is that it should come out of the box set up for HTTPS.
And so when you deploy an application, it should come with all the structure in a pre-secured state.
And if you made a bad decision in your building process to use HTTP, you're going to have to go modify the application load balancer's configuration to make HTTP work. That's all I'm saying.
But by necessity, that means that load balancer will have to have some kind of way to stand up with already a valid certificate. So who's going to own that certificate? The CSP or the business?
By default,
the CSP might.
The CSP generates them and handles the certificate management for you.
So that's
like Let's Encrypt would.
That's one more line item for the CSP to take from you. $195 a month for your certificates that you didn't do by yourself.
They're pennies. Their certificates are dirt cheap now from cloud service providers.
They are, but it's a chance for them not to be dirt cheap for the small business that's just trying. You see my point here? It's a great way of getting $194.
Yeah, but
you're
so much
pessimist, obviously.
Yeah, there's so much competition. How many primary cloud service providers are there right now? There's Amazon, AWS, Google, and Microsoft, and then you could say there's some secondary tier. There's probably 100 secondary tier cloud service providers.
And that was
you could even argue Rackspace might be closer to the big folks than
Mhm.
some of the other ones are. So I don't have a concern that somebody's going to try to price inflate cloud services when certificates are a commodity at this point, right? Right. That's what AWS brought to the cloud environment in the early days, is commoditizing all of these things and charging fractions of pennies for things.
They are for the people who know what a certificate is. For the use case that Matt is describing, certificate certificate. They don't know what it is. They just want things to work. You want to
right.
put that.
So if you get a site from Squarespace, doesn't it come with a TLS cert as part of the subscription?
I am not equipped to answer that question.
I mean, I'm pretty
Let's
sure
assume
it's
that
that
yes.
one. I'm pretty
Let's
sure it's a
assume that
one-click
yes.
thing. I'm pretty sure it's a one-click thing. I need an
It is.
application. I need it to be at this URL. Go do it, and it makes it happen. Right?
Yes, but now transfer that to the CSP. Now you don't have that one click anymore. The TSP is just
Yes.
saying, hey, as part of your service, as part of it, by the way, here's $100 more on your
But
bill.
the people who want this just to work are not working with a cloud service provider directly. They're working with some third party. To your example, a
That's a
GoDaddy, a
good point.
Squarespace.
That's
Like,
a
they're
good
not
point.
in there trying to figure out certificates. They're just expecting to swipe their credit card for a website. And so that does play back into what this article is saying, though. That website you get from a GoDaddy should have a secure default, in that it should have a certificate that that user doesn't even need to know exists. All they know is
Sure.
the URL is HTTPS to get.
But now who's responsible for that certificate? GoDaddy or the CSP?
In that point,
That GoDaddy decides who it is.
GoDaddy is the CSP in that environment, right? GoDaddy is effectively running their own data centers, I think. I don't think
Well, even if they're leasing it from AWS, right? Let's just say for a moment there's a relationship there of a front end provider and a back end provider. The front end provider should be managing that relationship, right?
So it's transparent.
Yeah.
There's no
so
visibility into the back end for
Yeah,
like
and
if
so
I
the
buy a website on GoDaddy, I don't see AWS ever.
Right. And so what's the shared fate model then? And so we come back to whose fate is it? So
Yeah.
the CSP taking on more ownership means they have better control and the ability to defend their infrastructure. You as the consumer, in theory, get some benefit from that, because the more uptime they have, the more uptime you have. And they do more, they take on more of the responsibility, but it also becomes more of a collaboration, right? They provide more secure defaults out of the box. And they want to collaborate with you to the first point, right? Better collaboration and better service delivery. Because if you don't know what you're doing and you say, oh, I don't need HTTPS, I turn off the TLS cert, their systems are now at risk. And their other customers are now at risk.
Their systems are at risk because I don't use HTTPS?
Sure. Because traffic can be intercepted or modified, right?
But it's my traffic.
Well, hold on. It may be, though, let's just say for a moment, you have a company that's full of lawyers and decide that, I lose data. Guess who's getting their first call? The lawyer for this hosting provider that, where your data is stored and has now been compromised. So there's there's non-technical reasons for this to be a positive for the cloud service provider, right?
Yeah, let's put it like this. If it is the way that you guys describe it, then yeah, it's a net positive. I'm still struggling with the shared fate here. Like, if I'm a user of the CSP and my mistakes can bring down the CSP, I probably need a different CSP.
Well, not necessarily bring down. Let's be careful, right? Taking down a cloud service provider is a hard problem, just by design, right?
Then what are we sharing here? What's the fate?
Shared fate is the outcome, right? It's not shared responsibility. Is more like nothing's happened. Shared fate is like admitting something's going to happen here. And so whatever happens to both of us. It happens to you as the provider. It happens to me as the person who's trying to deliver my application.
But
Right.
it doesn't.
Well, to some extent, right? If you get breached if you get breached, depending on how that breach happens, either your data is lost or the system that's hosted is corrupt.
And in a good design, that system should be isolated enough so that it doesn't interfere with anybody else's. So what's the threat model here?
I mean, there's been escapes before. There's been VM escapes, for example.
And you
It's not
escape to the
unheard of.
host. Now what?
If you're on the host, if you do a VM escape inside of a cloud provider, aren't you at the cloud provider's infrastructure? If you're at the host,
Don't we have that whole VPC thing and whatnot, and
It's still
things
shared
should
service.
be
It's still
separated and
it's got to break down somewhere. If you can
Not
no
by ten-
multi-tenancy and all that good stuff.
a
I mean, if you
multi-tenancy,
break out,
just
it depends
means
on how
that-
the tenancy model is done, right? It depends on whether you're given, it depends on whether you're given exclusive access to a collection of CPUs.
so now I'm interfering with a different tenant.
but that
Still not the CSP, but that reflects badly on the CSP. But the CSP is still
I'm saying there's got to
running
be a
and churning.
way. There's got to be a way to the CSP if you can escape the VM. If I'm at
Okay,
the
that's
host
scary.
level of the provider, then there's got to be a way to get to the next. And I mean, I don't know that unless you were running in the shared or at a dedicated CPU mode that you just, I think Matt mentioned. Challenge with that is it's uber expensive. Like it's
Right,
it's-
exactly.
Most people don't use it because it's thousands and thousands of dollars per instance per month
but
to have
still,
a dedicated instance.
okay, so you're going to break out, and you are now inside their network, but you are inside their operational network. You're not in the backplane. You're not in at the service level thing. You're not getting ready, getting close to their authentication stuff. There are so many bumps in the road here. That is this really a problem? And how is this different from what we have today? Like the shared responsibility model, you can still do all those things. So how is the CSP deciding that from now on everything's HTTPS going to save anybody from this? I'm having a problem with the whole threat
Well,
model here.
it's less interfaces. If you enforce secure defaults, it's less potential insecure interfaces for the attackers
Fair.
to have to work with.
Fair, but I would propose that on a good enough design to be a commercial CSP, you would have done that from the start, included it in your threat model, in your design, and actually have some mitigation and some controls against that kind of
I
thing.
think you're too pie in the sky here. I don't think you're
And
living
we're
in reality.
We're starting to circle here a bit.
Could be.
I need to run. So
Okay,
time out.
well, let's. Yeah, I mean, we really took a pretty simple article and turned it into a 30-minute deep dive. But it was good. I think this was fun to think about the philosophy of the cloud is really where we were here. So we are all officially philosophers now. So you will get a certificate in the mail. It says Cloud Philosopher. That'll be a picture of Izar doing that pose in the background, and it'll go on the t-shirt. So Cloud Philosopher. So folks, thanks for listening to another episode of the Security Table. We'll be back next week to talk about some other topic.